Can Python PDB trace exceptions inside library code? Imagine you're trying to fix a bug in your Python program, but the error pops up deep inside a library you didn't write. How do you find out what went wrong? That's where Python's built-in debugger, the Python debugger or PDB, comes into play. PDB is a powerful tool that helps you step through your code, set breakpoints, and examine variables. But can it also help you trace exceptions inside library code? The answer is yes, it can. When an exception occurs in Python, PDB can be used to investigate what caused it, even if it happened inside a library. One way is through post-mortem debugging. You can call PDB PM after an exception to inspect the traceback. This lets you see all the frames in the call stack, including those inside the library functions. You can navigate up and down these frames to understand how the error propagated. This is especially helpful when you don't have direct control over the library code but need to see what went wrong. Another method is setting breakpoints directly inside the library code. If you have access to the source files, you can insert PDB set trace at specific points in the library. When your program runs and hits that point, PDB pauses execution, letting you step through the library code line by line. This way, you can observe the state of variables just before an exception occurs. You can also use PDB commands to set breakpoints at particular functions or lines, making it easier to pause exactly where you want. You can also customize Python's exception hook, called sysExceptHook, to automatically launch PDB whenever an uncaught exception happens. This means if an error occurs inside a library, PDB will start right at the point of failure. It saves you from manually setting breakpoints and allows you to see what caused the exception in real time. If your code involves chained exceptions, PDB supports commands to view and switch between them. This helps you understand complex error chains that often happen when libraries re-raise exceptions or wrap errors. You can see the full picture of what went wrong and where. However, there are some limitations. If the library is a compiled extension written in C, PDB cannot step through that code because it only works with Python bytecode. Also, if the library is installed as a binary package without source code, you can't set breakpoints directly inside it. Instead, you're relying on post-mortem debugging to examine the traceback. To make debugging easier, you can insert PDB settrace in your own code before calling library functions suspected of causing errors. Wrapping library calls in try-except blocks and calling PDB post-mortem inside the exception handler is another good strategy. It allows you to pause and examine the call stack at the exact moment of failure. You can also enhance your debugging by customizing sysExceptHook to automatically invoke PDB on any uncaught exception. Using commands like where, up, down, and list inside PDB helps you navigate the call stack and inspect the library code involved. In summary, PDB is capable of tracing exceptions inside library code through post-mortem debugging, setting breakpoints, and customizing exception handling. These techniques give you the control to understand and fix bugs even when they happen deep inside external libraries. Mastering these methods makes your debugging sessions more effective and your code more reliable.